Hey everyone, welcome to another problem session. So today we are continuing our solution of the 2023 IIT JEE exam. So we have paper 1 already done. We're going to do paper 2 today. Maybe a couple of sections of paper 2 today. And each problem will be posted as a separate video. So let's get to it. So here is a for section 1. It's a four questions in section 1, and it's a multiple choice, and there are 4 answers, and there's only one of them is right. So if you don't get the choices that are given to you, that's already in hint that something went wrong. So it's not like finding an answer and then moving on. Maybe finding an answer and maybe it doesn't work out right, but you're sure that you have the procedure right, then there may be some numerical problem in some of the steps. It's very easy to make numerical mistake, sometimes changing the units is a problem. Something was in millimeter and you forgot, and it's just worked out very weirdly. So we've got to watch out for that. Now if you because there's a negative mark is very fair here, because there are 4 choices. Like for this problem we have a 4 choice here, and one of these choices is correct. Now we don't know which one is correct. Suppose for some reason, some argument you have, some physical sense you have, from that you ruled out A and C, then the answer has to be B or D, but you don't know which one is correct. It's okay to guess at that point, because now instead of probability of wrong being 1 out of 4, now probability of wrong is 1 out of 2. And so, but the gain is +3 and loss is -1. So in that case you have a net gain by guessing, even if you happen to guess wrong in one of the questions. Maybe if you had the same situation happen again and again in multiple questions, you will come up ahead in that case. All right, so it's okay to guess as long as you can eliminate. It's hard to eliminate in the numerical problems, by the way. All of the answers look very similar. All right, so that's the strategy part. How do you solve this problem? This is a problem of electric dipole. There's a minus charge and plus, same amount of plus charge. So this is an electric dipole, and it's a very small size. It's actually 4 millimeter here, and field point from the electric potential from here that we're going to look at over here is very far away, which is kind of, when you have broken line, that means this distance is not to scale here, just very far away. And x distance is 100 millimeter, so x distance is about 50 times this distance here, or maybe 25 times the size of dipole, and 25 times, we can just say it's really practically infinite, very far away. And so when you look from here, we can use a point dipole formula to answer this question. Okay, it doesn't say here that you can use a point dipole, and they should do it. I didn't see it here when I was reading it earlier. So it does say dipole and doesn't say you can use a point dipole. Okay, so some things, what do you have to know to answer this question about point dipole? So so-called point dipole. So if you have a minus q and plus q and a distance is d, then you can associate something called dipole moment, or electric dipole moment, and say P equals to QD. And there's a P vector with the magnitude P and some unit vector that goes from minus to plus. So you can say dipole vector is that way. So there is a special direction, and from the center of this, so here's the this is a field point. That's where we want electric field, electric potential from this. Okay, so what is the electric potential at this point? It's 1/4 pi epsilon naught, which sometimes written as K, and P, but because there's a special direction, this angle matters. Let's call it theta, cosine theta over this distance r, but r square. Contrast this formula to if you had just one of these charges, some q. Now there's no, every direction is uniform same. So if I go distance r, in this case this is called monopole or single pole or point pole, point charge, point monopole or point charge. In this case V at P is 1/4 pi epsilon naught. You know, epsilon naught is electric permittivity of vacuum. I'm assuming there's a vacuum around here. There's a vacuum around here. So this one is Q over R, and this one is R square. So you can see that this one dries out with distance much more quickly than this one. This is called dipole potential. Now, if you don't remember this formula, then this can be attacked by just using this from this charge and not using that charge, and it can become unwieldy, and you have to do some approximation. So this one something you have to remember to solve this very quickly in the exam situation. That's what we are in exam setting. Okay, so in this problem we are going to just do it really quickly, very easily done. So there are two situations. In one situation what we have is dipole is this way with a distance say d0, you have minus q, you have plus q, and from here some distance r, potential is v0. And there's another situation which is not this way. So this is like x-axis, this is the y-axis. This guy's so this distance is d1, and d1 is this minus q plus q. The potential dipole is that way, this dipole is that way, but the field point is same point P. And let's see, this is v1, and I have to write v1 in terms of v0. So let's write these guys out, what we expect for v0 here. So this angle, which is you can already see from here, let's call it theta 0. So I'm going to write k. I'm going to write k equals 1/4 pi epsilon naught. I'm going to write like that just to save time. And P cosine theta 0 over R square. Over here we need this angle. This is going to be theta, and theta is let's call this P. P is here. Let's call P equals Q d0. Let's denote this by P0. So I'm going to use P0. Over here, this distance d1, d0 is 4 millimeter here. D1, this is this from here is 1 millimeter and this from here is 2 millimeters. So this distance is square root of 5 millimeter. So D1 is 2 square root of 5, and so the P1 dipole moment is Q times 2 square root of 5, and this theta, so if this angle down here is phi and this angle down here is theta 0, then theta is theta 0 plus phi. For phi, this is the phi, and this is 2 and this is 1. So let's write down here. So V1 is going to be K P1 same R square cosine theta 0 plus phi. So now if you take a ratio of these two, should give me the answer. So V1 over V0. So all of these got P1 over P0 cosine theta 0 plus phi over cosine theta 0, and then we can actually work this out, right? So P1, I don't even need to note Q, but Q is the same and cancels out. So so P1 is Q times 2 square root of 2 square root of 5, and this is Q times 2 times 2. Okay. And then this is cosine theta 0 cosine phi minus sine theta 0 sine phi divided by cosine theta 0 divided by cosine theta 0. But theta 0 is 45 degrees, so this cancels, and this is same as that. So for this, sine theta 0 is equal to cosine theta 0, so this cancels that. So I just need a difference of cosine phi minus sine phi. So this is 5. So 2 square root of 5, 2 over square root of 5. So this is 2 over square root of 5, and this is 1 over square root of 5. And this whole thing is 1 over square root of 5. So Q cancels out, 2 cancels out. So it's square root of 5 over 2 from here, and this is 1 over square root of 5 cancels out. And so I got an answer half. So V1 is half V0. And let's check it out. What do we have? Choices that we have as kind of an answer. Choices we have is there's a B here. Make sure that B, yeah, everything is. So the answer is B. Okay. So that's how we can solve this problem very quickly. I think basically 2 minutes of work and it should be done. A problem like this, you have to be prepared with this formula. It's an important formula. This formula, along with K Q over R for point charge potential, this to be memorized. This is dipole potential before you come to the test. All right, take care. We're going to do the second problem in the next video. It's actually a really good problem and has to do with dimensional analysis. You will see the second problem coming up in the next video. All right, bye.